Hello. Today we are going to continue our study of polar points and polar equations, but we're actually going to be looking at polar equations and points in the terms of a graph. So we learned last time that we can graph on this circular system. We know that we talk about directed angles that begin here at the polar axis, and remember this point here was called the pole, and then open this way and terminate on one of these lines that would mark an angle. So when we're looking at these graphs today, we're going to graph them, and we're also going to look at characteristics of those graphs. In this first one, let's talk, the first main characteristic is symmetry. So when you have the symmetry on a graph, that means it's kind of like an, orientation, if you will. So if it is a sine equation, then it's with respect to the pi over 2. If it is a cosine equation, then it's with respect to the polar axis. So remember, the polar axis is the one that's right here, starting at the positive x-axis, and then your angle opens this way away from it. And that point right there in the middle of all of that is the pole. Don't forget, that has a name, so that's the pole right here. Okay? So just terms that I want you to be familiar with in terms of symmetry. So now we're actually going to graph these four angles. Or graphs, make these four equations, there we go, on a graph. So this is going to be my number 1, and it is going to be r equals 4 sine theta. Alright, then I'm going to make this one down here my 2, so just be sure and label, it doesn't matter if you make that 2 or not. So I'm going to do r equals 3 plus 2 cosine theta down here. And then my 3 is going to be up here, and I'm going to do r equals 1 minus 2 cosine theta here. And then this one is going to be my 4, which is going to be r equals 3 cosine 2 theta. So when you're doing your graphs, that way you'll just kind of know what order I'm graphing on my page. But you can go in any order as long as you're just labeling what you have. All right. So as we are going through this graph, we have a polar graph help sheet. So we're talking about the polar graph and a couple of things that we want to keep in mind. And it's also on the note sheet right here. So you have it written down so you don't have to be scrambling. But on your help sheet, if it's a cosine equation, its symmetry is with respect to the pole axis. And if it's a sine equation, its symmetry is with respect to the pi over 2 axis. So that's just stating what we just looked at in our notes. But I wanted you to know that it was there here as well. So we have different groups of polar graphs. This first one is a limacon. And you can see there are different kinds of limacons. Then we have a rose curve, which makes pretty flower pictures. And then our last group will be circles and lemniscates. So this is the one that's like the figure 8s and the circles. So if we're looking at the equation for a limacon, it's going to be r equals a plus or minus b cosine theta. Cosine would be symmetric with respect to the pole axis. Or we could have r equals a plus or minus b sine theta, which would be symmetric with respect to the pi over 2 axis. And then these things right here, this a and this b value, tell you which kind of graph you're looking at. So we're going to look and compare a over b as a fraction. So if you compare a over b and it's less than 1, it's going to produce this limacon that has this inner loop that develops. And oftentimes when I'm graphing that, that's like we start reversing directions like we do when we graph in vectors. If a over b equals 1, then it's a cardioid, which is just basically a heart-shaped limacon. If a over b is between 1 and 2, then you're going to get a dimple. So you're going to get the basic general nice curve here, and then it's just going to kind of come in for a little bit, not significant enough to make a point. It's just going to be like, think of your pushing your thumb in on something and it just kind of makes a little dent. And then finally, if a over b is greater than 2, it's going to be convex limacon. So you can see it comes out instead of pushing in, and so that just is a little different shape. On the rose graphs, we have the form y equals a cosine in theta, or r equals a sine in theta. And so there's a lot of pieces, or a lot more pieces, to the rose graph. So the first thing is this a value that's in front of all of them will tell you the length of the petal. So you get the length here and you length here. you still can look at their symmetry, and if it's a cosine equation like these two, then it would be symmetric with respect to the pole axis. If it's a sine equation like these two, its symmetry is with respect to the pi over 2 axis. Okay, then the next thing is how many petals do we have? So that is where we look at this n value right here, and we need to decide if it's even or odd. If n is odd, then the number of petals will be the same as n. So if this is 4 or 5 theta in here, 5 is odd, so it's going to have 5 petals. If n is even, that's the number in here is even, then we're going to multiply it by 2, and that's going to tell us the number of petals. So you can see symmetry is kind of a big deal because depending on where the petal is, has a lot to do with the equation and what it looks like. And then finally our last group, which is a circle and lemniscate. So there's actually 2 in this one, but we can have a circle who has, when it's cosine, has symmetry with respect to the pole axis. So you can see it's symmetry, like cutting it right here. And then when you do a sine of theta, you get a circle, and you know that it is going to be symmetric with respect to the pi over 2 axis. In this case, the A determines the width of the circle. Remember, in this case, it told us the length of the petal. Okay? So then we move on to lemniscate, which looks like figure 8s, and they can be with respect to the axis or not. That equation is r squared equals a squared sine 2 theta, and r squared equals a squared cosine 2 theta. So these equations look a little bit different down here. And remember that a is the length of that loop right there. So that's everything that is on the help sheet. So you have access to this on Canvas, and I did print you one just so you'll have a copy. Okay, so now we're going to begin by graphing this one, and you are going to need your calculator at this point. So let me get the glare off here. So the first thing we're going to do is begin with a fresh calculator. So do second plus 712, and let's clear this out. So everybody is pushing and changing their information as we go. All right, so the first thing I want to do is press the mode button, and I'm in polar mode. So if you go down here to where it says function, you can actually arrow over past parametric, this time to polar, and hit enter. Okay, that means when I press the xt theta button, I'm going to get theta this time instead of the other 2 functions. Then I'm going to go up here and I'm going to press and change from radians to degrees. And the reason I'm doing that is if you look at your circles here that you're graphing on, they are all in increments in degrees, so we're just going to go with that. All right, so then we're going to go to y equals, and you can see now in the menu here it's not y equals or x1t, y1t, it's r1 equals. So we're going to put our equation in there. We're going to do 4 sine theta and then we're going to go to our window and we're going to do a little change here because remember I'm in degrees, so I want to go 0 to 360 degrees once around the circle. I'm going to change this to, like, let's just try 1, so it's going to measure every degree. And then I don't believe any of these are huge, so I'm just going to make this a little smaller, and let's say 6 to 6 to 6 to 6. All right, so now what my paper says, remember, is that I'm counting every 15 degrees. So I'm going to go up here to my theta step and make that 15 so it kind of matches my paper. And then I am going to graph it. Okay, so I'm hoping that you see a couple of things. One, there's a lot of little flat spaces on here, which we learned in previous units that means that the t-step, or in this case the theta step, is too far apart, so you're getting that flat line. So I'm going to need to do something about that. So this is going to look like an egg shape here, but I need it to look more circular. Because if I go back to my help sheet and I come down here, I can see that I need 4 sine theta, and here's this equation that has a number sine theta, and so my number here is what I'm looking at, which happens to be 4. So we know that the 4 is the distance across the circle. So if you remember from the last unit, if I press zoom and I press square, I can make that look more circular because it's making the same number of pixels going horizontally as go vertically. And so it kind of squares it up and makes that look a little bit better. So now the next thing I'm going to have you adjust on your calculator is this place right here where it says table set, which is right above the window. So I'm going to press the blue button and press window. And I'm going to start my table at 0. And I'm going to change my table every 15 degrees. And I am going to let it do auto. So now when I graph, I've got this, so nothing's happened there. And I can do second table and I can see a value. So look at the heading here is theta and the heading here is r sub 1. Let me zoom in just a little bit so you can see my calculator a little bit better. And we'll just kind of make some adjustments here. All right, so that's a little bit better. I can see a little bit better, clearer. And so you can see that this is r in the table and this is theta, and it's counting by 15 degrees just like the circle. So you don't have to write a table. We're going to use the calculator. But out beside each distance, I want you to write the value of that. So for instance, here in this equation that we put in here, which is 4 sine theta, when I go to the table, at 0, I'm at the pole. So that's this point in here. So we're going to have this point right there. And then at 15 degrees, so we're going to go to the angle that's 15 degrees. And in my table, it says 1.04. All right, thanks for your patience. I have a light right over my desk that is causing some blur on the calculator screen, so I was kind of playing with some different light settings to see if I could make it a little easier for you to see. So I hope that you can. All right, so I am going to go to my table, and at 15 degrees, that's the next line here on my graph. So I'm going to go and use the tenths place here. So on this 15 degrees, I'm going to go to 1.0, and that just came out of my table. And so at 15, I'm going to go 1 unit down on my graph. So down the 15 degree line, I'm going to go 1 unit, and that's going to put something right there. Then I'm going to go to the next value in my table, which is 30 degrees, and I'm going to be at 2. So now I'm going to go down the 30 line, and I'm going to go out 2 rings down here. 1, 2. All right, then I'm going to go down to 45, and that's 2.8. So before we get much further, I want you to get in the habit when you're graphing here. So at 0, the R value is 0. At 15, the R value was 1. At 30, the R value is 2. At 45, the R value is 2.8. So then on this 45 degree line, I'm going to go 1, 2, and 8 is a little more than halfway, but not quite underneath the line. And then I'm moving on to 60. So at 60, it's 3.46, so 3.5. And so here on the 60 line, I'm going to go 1, 2, 3.5 would be halfway down. All right, so then we go on to 75, and we would do 3.9. So that means from the pole, 1, 2, 3, and just under that marker right there. And then the next one would be for the 90 degree line, which is 4. And so then I'm going to go from here, 1, 2, 3, 4, down the 90 line. Now this is where you can keep calculating if you would rather, or you can mark that axis of symmetry line, which for me is going to be right here. And so why that's kind of a big deal is if I know that that's the axis of symmetry, now instead of having to continue to calculate like I'm doing right here, I can reflect the points over. So I know this is going to be 3.9, this is going to be 3.5, and this is going to be 2.8, and this is going to be 2, and this is going to be 1, and this is going to be 0. All right. So the next one, 3.9, is going to mirror this point right over here, across the axis of symmetry. And then this point is going to get mirrored like roughly here. and then this point is going to get mirrored here. And this line right here is going to get mirrored over as well. So now we're on 2.8, 1, 2, see 1, 2. Oh, that was 2.8. This is just 2. Sorry. Got my lines off. 1, 2. Right here. And then 1. And then you're back to where you started. So then when you play dot to dot and you connect the dots, you have this graph. So before we ever started, we would have wrote down some things that we know about the graph. For instance, we know this is going to be r equals a sine theta. So I can tell a is 4, and the significance of a being 4 circles that distance across the circle. So a is 4. And then the symmetry, because we're using a sine function, will be when theta is pi over 2. It is a circle. So what else do we know about this? We're pretty good there, right? Okay, so that's what this one is. So now we're going to look at 2, which is 3 plus 2 cosine theta, and we're going to talk about what we know. So before we do that, I am going to switch papers here, just so you can see that I did blow one up, so you can see the points a little bit better in case you need it. So this kind of goes through the ask table instructions down here at the bottom if you need them. And this is what that would look like. So you can see where I'm labeling my points around and I'm getting my answer there. All right, let's try another one. So we're going to come down here to our 3 plus 2 cosine theta. So what kind is it? Well, we didn't write this as a circle up here. Sorry, I forgot to include what it was. So down here, what kind of graph is it going to be? It's going to be a limacon with, what kind of limacon? Involves, good. So that means it looks like someone took their thumb and pushed it in. The symmetry is polar axis. A is 3, B is 2, so 3 over 2 falls between 1 and 2. So I think that about does it. So pause the video and go calculate these points. Remember to write them on the outside of the circle and get a graph for me. All right, so here we go. So we got all of the line or R calculations out of the calculator. We know we're looking for points that are R comma theta. So this, based on this equation, it is a limacon with a dimple equation. A is 3, B is 2, 3 over 2 is between 1 and 2. So she knows what that's going to look like, right? Or who knows when you're looking at your graph. So then we plotted all the points, and you should be able to see the little indentation there. All right, that's question 2. Question 3, so we're doing r equals 1 minus 2 cosine theta. So look at your list of equations on your note sheet, and you hopefully see that this is r equals a minus b cosine theta. It is a limacon. With an inner loop, and its symmetry is polar axis. Okay, so we know its symmetry. What about, we did check A is 1, B is 2, so we know that's less than 1. So I think we're in a pretty good place to graph it. So pause your video and graph number 3. All right, so here is number 3 graph. You can see that that loop opens up in here. You can see what its axis of symmetry is. And hopefully maybe you're using the axis of symmetry to kind of help you calculate those points. So this is number 3, a limacon with an inner loop. All right, so now I am on the last one, number 4, and it is r equals 3 cosine 2 theta. So when I go to my graphs, I will be thinking of r equals a cosine I think it's 110. All right, so it's a rose curve. N equals 2, which is even. So the number of petals is 2 times whatever that n is. So the number of petals is 4. A is the length of it, and according to this particular equation, A is 3. So, axis of symmetry? Well, let's see. It is a cosine. So even though it may look symmetrical to different axes, technically it is described by what's given. So I would say, let's see, do I have my axis? Oh yeah, my axis of symmetry is going to be cosine, and so we know that cosine is polar axis. So now change this equation in your graphing calculator, label the points around, and graph. Pause your video and take care of that. All right, so this is number 4. It is a rose curve. You can see its symmetry there. You can see that the length of those petals are 3 units. That means from like here, 1, 2, 3 rings across. In this one, here's my symmetry axis right here. And if you look at it this way and this way, it's definitely symmetrical. But because it's also around that vertical line, it kind of looks that way too. But you always want to rely on the definition based on the equation. So that makes it kind of fun. So let's look at this one on the calculator for a minute. And I'm going to do y equals, and I'm going to do 3 cosine 2 theta. So I get my graph there. That's what you see. So if I wanted to change the number of petals, remember that this number in here says that. So let's say I want to change it to 4 petals and keep it even. And then when you see the graph, it looks like that. Why am I getting those little pointy things? Who remembers? Well, hopefully you just said because of the theta step. So if I'm in here my window and this is counting by 15, I'm perfectly happy doing that here. I know how to make my graph curve, right? But on a calculator, if those steps are too far apart, then it starts trying to connect it with a flat line. So I would probably go down here and change it to 1, so it's going to draw by 1 degree. And then you can see that my graph does look significantly different and not all pointy when I'm actually graphing in a unit that I would like to graph in. And so that's always kind of fun. So you get something like that. So that we just changed in. Well, what if we change the length of the petal and we make it 4? You can see they get longer, but nothing else would have changed. So there is that. So by changing characteristics, you change the type of graph. So the next thing that we're going to do is a quick little assessment. And you are going to pick a card, any card from my deck of equations. And then your group will have 5 minutes to create a parametric equation that contains your characteristics. So you are going to present it to the class. So you're going to have your equation as well as the graph. So you could do this and show me the equation, and you can do this and show me the graph. And so you're going to do that, and then you're going to explain why the things you pick make the kind of graph that you got. So when I'm saying you're going to draw, I have graphs set up for all these different things. So maybe you draw one with a limacon with an inner loop, and it tells you it needs to be symmetrical with respect to the y-axis or the pi over 2 axis, and it tells you that, might have other characteristics. So like on a rose, it could say, I want a petal length of this, and I want this many petals. And so you need to figure out which equation will get you that, and then that's your presentation